Have you ever wondered how metals form rust over time? Or how a simple pocket lighter instantly produces fire? These chemical processes seem random, but they are all fundamental reactions governed by a strict law of physics. According to John Dalton's atomic theory, atoms cannot be created, and it cannot be destroyed during chemical reactions. This is the fundamental rule we follow whenever we're balancing reactions. Whatever the number of atoms you start with as reactants must exactly equal the total number of atoms you have left over as products. One example is when methane, a natural occurring gas, reacts with oxygen and burns in air to form carbon dioxide in water. On both the reactants and products side, there's 1 carbon atom, 4 hydrogen atoms, and 4 oxygen atoms. So this is an already balanced chemical equation. But a lot of chemical equations are not yet balanced at the beginning, like these reaction. In those cases, yes, we have to balance them ourselves. So going back, how do metal forms rust? When solid iron is exposed to the air, it gets oxidized by the oxygen gas. However, oxygen gas by itself doesn't react very fast with a dry iron. You need water to act as an electrolyte, a fluid pathway that allows electrons and ions to move around easily so the oxidation occurs. When it happens, the reaction forms iron 3 oxide, which is the orange flaky material commonly called as rust. So our chemical equation is iron reacting with oxygen gas to form iron 3 oxide. On the reactant side, we have 1 iron atom and 2 oxygen atoms. On the product side, we have 2 iron atoms and 3 oxygen atoms. The number of iron and oxygen atoms are different on opposite sides, so this is an unbalanced equation, and we will balance it. But before we proceed to balancing, you must remember 2 rules. Rule number 1, we must balance equations in the following order: metals first, then nonmetals, oxygen, and hydrogen. You can use this periodic table to identify whether certain atoms are metals or not. Rule number 2, change the coefficients only, not the subscripts. Take this water molecule, for example. If you add a coefficient of 2, you will get 2 molecules of water. Coefficients only changes the number of atoms or molecules, and that allows us to balance chemical equations. But if you change the subscript, say you turn the oxygen subscript into 2, you'd get hydrogen peroxide, which is a powerful cleaning agent. Peroxides are a totally different substance than water, so never change subscripts. Back to our equation, let's balance the iron metal first. However, you can also balance pure solid metals last. Anyway, multiply the reactant iron by 2 to balance iron. Each time we multiply, we make the multiplier as the coefficient in the equation. Moving on to the oxygen atoms, clearly they weren't balanced. Since 2 and 3 have no common factor other than 1, cross-multiply them. Multiply the reactant oxygen by 3 and the product oxygen by 2. Oxygen atoms are now balanced at 6, but on the product side, multiplying oxygen by 2 also made us multiply the iron by 2. Regain the balance by multiplying the reactant iron once more by 2. The iron atoms are also now balanced. So is the whole chemical equation. This is a standard flint lighter. Before we unravel the chemistry behind it, let's break it open, and I'm going to tell you how it works. The body of a lighter is where liquid butane is stored. To produce a fire, you need to do 2 things simultaneously. Rotate the steel wheel and push down the lever button, all in one motion with your thumb. As you press down on the lever, the gas channel opens up, depressurizing the butane inside, allowing it to escape as a gas. Once the butane gas molecules has reached the air, they immediately encounter oxygen gas, but they don't react just yet. According to the fire triangle, you need heat to reach a certain activation energy needed to cause combustion. Fortunately, That needed heat is provided by the spark produced when the steel wheel is rotated against the flint below. A combustion reaction is successful. Our equation is butane C4H10 reacts with O2 to form CO2 and H2O. On the reactant side, there are 4 carbon atoms, 10 hydrogen atoms, and 2 oxygen atoms. On the product side, we have 1 carbon atom, 2 hydrogen atoms, and 2 + 1 oxygen atoms. Do not add and write 3 for oxygen, as it exists on both CO2 and H2O. Let's balance the carbon atoms. Multiply the carbon product by 4 to match 4 carbon atoms on the reactant. Multiplying carbon dioxide by 4 means we have to multiply its oxygen by 4 as well. Next, multiply the hydrogen product by 5 to match 10 hydrogen atoms on the reactant. Multiplying H2O by 5 means we have to multiply its oxygen by 5 as well. Simplify all the expressions on the product side. We have 4 carbon atoms, 10 hydrogen atoms, and 13 oxygen atoms. Finally, multiply the reactant oxygen by the fraction 13/2 to balance the oxygen atoms at 13. At this point, all the atoms in the reaction are balanced, which means the chemical equation is already balanced. However, we are not yet done because the oxygen's coefficient is a fraction. Remove the fraction by multiplying both sides by 2. The final balanced equation is shown. Thanks for watching.